This is your space news for February 28th, 2019. There was a lot that happened in our solar system this week, so let's get this thing started with space traffic.
Hello everyone, welcome to your space traffic report. And first up, we have a Soyuz-2.1B rocket that launched from the Baikonur Cosmodrome on Thursday, February 21st at 1647 Coordinated Universal Time. Now, we couldn't actually find footage of this particular launch, so what you're seeing on screen is the last Baikonur launch of a Soyuz that occurred at night. But for this launch that occurred on Thursday, February 21st, the payload on board the Soyuz was called EgyptSat-A. It's an Egyptian Earth observation satellite headed into a polar orbit at an altitude of more than 650 kilometers, or 400 miles. And it's intended to provide the Egyptian military and other government agencies with high-resolution surveillance imagery. So it's a spy sat. Apparently, there was an anomaly with either the third stage of the Soyuz or the Fregat upper stage. Russian news agencies reported that EgyptSat-A and its Fregat upper stage were tracked in a lower than expected orbit after separation from the three-stage Soyuz booster, around 9 minutes after liftoff. If the anomaly was with the Fregat upper stage, then the impact to Soyuz launches may be minimal. However, if the anomaly was with the third stage of the Soyuz, that could have deeper consequences, as the third stage is used on all Soyuz rockets, including those variants that fly humans to the International Space Station. But we don't have a root cause yet, and everything is still just speculation. However, contingency burns by the Fregat upper stage appeared to have corrected the apparent performance shortfall, and in the end, Russian officials said that EgyptSat-A was released at the expected altitude, and that the solar panels on the satellite unfurled as designed. Next up, though, we have a Falcon 9 Block 5 rocket that launched from Space Launch Complex 40 at Cape Canaveral, Florida on Friday, February 22nd at 1:45 Coordinated Universal Time. The payloads on board Falcon were an Indonesian communications satellite known as Nusantara 1, the Beresheet moon lander by Space-IL, the Israeli team, and an experimental U.S. Air Force Research Lab space surveillance microsatellite known simply as S5. But more on those payloads in a minute. The booster stage used some of its engines to steer toward and brake for a touchdown on the drone ship named Of Course I Still Love You. And according to Elon Musk on Twitter, this was the highest re-entry heating to date for a Falcon 9 booster landing. That's pretty crazy and really impressive. For this Falcon 9 booster, it was its third trip to space and back, following 2 missions that were launched last year, and it was the 34th successful landing of a Falcon booster overall. The Indonesian Nusantara 1 communications satellite was the primary passenger on the Falcon 9 rocket, and it's going to provide a 15-year telecommunications mission over Indonesia and Southeast Asia. The U.S. Air Force satellite, known as S5, rode piggyback on an adapter that was attached to the top of Nusantara 1. The spacecraft weighs only about 132 pounds, or 60 kilograms, and it will apparently demonstrate the capability of a small satellite to find objects in geostationary orbit, allowing the military to update its database. However, the first payload to be deployed on this mission was the Israeli moon lander from Space-IL named Beresheet. To find out more about the Beresheet lander, we actually covered it in detail a couple episodes ago, which you can see here if you click on the card, or in the links in the description below. In any case, I'm really excited because this moon-bound lander is going to fire its main engine several times over the coming weeks, beginning as soon as this Friday, to raise its altitude with a series of ever-growing loops around the Earth, setting up for its maneuver to ring into lunar orbit, sometime around April 4th. As it gets closer, we're definitely going to keep you in the loop. Meanwhile, we had a suborbital flight this week as well, on Friday, February 22nd at 16:54 Coordinated Universal Time. I'm talking about the second suborbital flight of Spaceship Two, VSS Unity, and it had 3 crew members on board this time. Pilots Dave McKay and Mike Masuki, and Chief Astronaut Trainer Beth Moses. On this flight, they reached a peak altitude of 89.9 kilometers, or 55.9 miles, which is a little bit higher than their last flight. Although it was running 2 days late because of high winds, Virgin Galactic Spaceship Two, again named VSS Unity, was carried from the Mojave Air and Spaceport by its mothership carrier plane known as White Knight 2 on Friday, and the whole flight appeared to go off without a hitch. The pilots guided the vehicle as it was released from its carrier plane. They ignited the rocket motor and guided it out of the discernible atmosphere. The rocket motor shut down normally about a minute after ignition, and the spacecraft coasted upward at a record for Virgin Galactic of 3.04 times the speed of sound. Spaceship Two made its first trip into space on December 13th, reaching an altitude of 51.4 miles. The two pilots on board that flight, Mark Stuckey and Steve J. Sturcow, a former space shuttle commander, were awarded commercial astronaut wings by the Federal Aviation Administration, the FAA, and their rocket motor was put on display at the Smithsonian National Air and Space Museum. That's pretty cool. On this flight, McKay and Masucci flew a similar flight profile as the first one, but Spaceship Two was rigged a little bit more as it would be for commercial flights, and the motor fired slightly longer as well, pushing the vehicle to a higher altitude. They also had a passenger of sorts in Beth Moses. As the spacecraft arced over the top of its trajectory, the crew experienced about 5 minutes of weightlessness as they enjoyed the view. How couldn't you? But having Beth Moses float in the cabin gave them data and experience just having someone floating around in the cabin for the first time on an operational flight. They made a safe landing, and all three of the crew were exhilarated and satisfied with their incredible experience. I'm very jealous of them and hope I get to experience it one day as well. However, you might be saying to yourself that there was even more space traffic in our solar system this week, and our resident astronomer has all the details about some activity around a near-Earth asteroid.
The incredible success story in the asteroid belt that is Hayabusa 2 continues to give us some great news. Back in 2005, Hayabusa 2's predecessor, the singularly named Hayabusa probe, arrived at asteroid Itokawa to perform a sample return mission. It was an incredible mission of engineering triumph over adversity. On the way to Itokawa in 2003, a powerful solar flare damaged its solar panels, reducing the power available to its ion engines. 2 reaction wheels failed in 2005, landing rehearsals failed, sample sites turned out to be rockier than expected, and damage occurred during sample collection attempts. But through all of these problems, Hayabusa remained the little spacecraft that could. It had collected a sample of Itokawa, several micrograms of dust from its surface, and returned it to Earth in 2010, leaving scientists hungry for more. Hayabusa 2 was launched in 2014 to be an even more comprehensive follow-on, with upgrades of Hayabusa's original instrument package and whole new systems for a whole new data set. Arriving at Ryugu in mid-2018, work began to find a suitable area for sample collection. Ryugu is a pretty interesting asteroid. It shows characteristics of C-type and G-type asteroids. C-type asteroids are extremely dark and rich in silicates and oxides. G-type asteroids contain phyllosilicates, things like clays or mica, and it's rather rare to find an asteroid like Ryugu which fits both. No site on Ryugu matched the collection criteria developed by scientists before arrival, so modifications to those criteria were made. 2 sites were chosen, and both were quite high risk, as they contained large boulders that Hayabusa 2 could potentially strike. But this past week, controllers commanded Hayabusa 2 to take a crack at it, and everything appears to have worked. Imagery relayed back from Hayabusa 2 shows its shadow with a dark patch on the surface of Ryugu. That's been caused by its attitude control thrusters firing to raise its altitude, pushing away older, lighter material that's been bleached over time by exposure to ultraviolet radiation. This exposes the darkened, unexposed regolith below. Telemetry indicates that Hayabusa 2's sample collection system made contact with Ryugu's surface and that a small impactor made of the element tantalum fired. Temperature changes in the sample collection system consistent with material entering it occurred, but we don't know how much material was grabbed, if any at all. We'll basically have to wait for the sample capsule to land on December 7th, 2020, and within a few weeks of that, we'll know for sure. But in a few weeks, Hayabusa 2 will deploy a 2.5 kilogram copper impactor that will be accelerated by a 4.5 kilogram shaped charge of oxygen, a type of plastic explosive. Now, Hayabusa 2 is going to duck to the other side of Ryugu to protect itself, but it will leave behind a camera that will at least attempt to see the impactor. After a few weeks of waiting for debris to settle, Hayabusa 2 will inspect the new crater and likely take another sample of the now exposed pristine subsurface material. An asteroid like Ryugu may contain the building blocks for life. And to talk about a potential doubling of those blocks, I'll hand it over to Sarah.
Good news, space fans. Life on other worlds may be even weirder than we've ever dreamed. A team called the Foundation for Applied Molecular Evolution, led by Dr. Stephen Benner, published a paper in Science on February 22nd. In their paper, they announced that they had synthesized a DNA molecule with 8 nucleotides. They dubbed their new DNA molecule Hachi-Moji. Hachi is Japanese for 8, Moji is letter.
Natural DNA, or deoxyribonucleic acid, is the code that contains all of the instructions for life as we know it. Here on Earth, DNA has evolved using just 4 nucleotides: adenine, thymine, cytosine, and guanine, or ATCG, hence the letters. Dr. Benner's team has successfully synthesized stable DNA strands that incorporate 4 synthetic nucleotides, P, Z, B, and S. The way DNA works in its basest form is an enzyme unzips the double helix by breaking the bonds between the nucleotide base pairs. Then the pattern of A's, T's, C's, and G's are copied and sent to the ribosome. The ribosome uses the transcribed RNA, or ribonucleic acid, to build amino acids into proteins that then carry out the functions that we call life. This is not the first time synthetic base pairs have been incorporated into DNA. In the past, successful experiments have managed to squeeze an additional base pair in between the naturally occurring 2, bringing the nucleotide count up to 6. But since the bonding method of these synthetics were different than the natural DNA, longer strands broke down if too many were sequenced together. Dr. Benner's team avoided that inherent weakness by creating these new synthetic bases by altering the original 4 molecules. So, C becomes Z, G becomes P, and just as C bonds with G, so Z bonds with P, etc. This stability allows for successful synthesis of RNA as well. This is all well and good, but when do we get the base 8 superhumans? At the moment, the DNA is only functional in the carefully controlled environs of the lab. So then the next question is, what is this good for? And one of the answers is data storage. Yep, computers store data in sequences of 1s and 0s. With 4 bases, natural DNA allows for greater data density, and the ability to synthesize new bases means we can store even more information, not in microprocessors, but in molecules themselves. And this is not something for the far-flung future. In 2017, researchers funded by the National Institutes of Health encoded this movie in the DNA of a bacterium. That means the ribosome may be the Blu-ray player of the future. The other answer to what is this good for is astrobiology. That's right, NASA's exobiology program is one of the organizations that funded this research in the hopes of determining if other molecular evolutionary paths could successfully produce life.
And the timing of this breakthrough couldn't have been better. We continue searching our little corner of the universe for signs of life, but we now know that we don't have to limit our searches to the familiar ACTG. And, in a bit of serendipity, the European Space Agency on February 7th announced that they named their ExoMars rover Rosalind Franklin in honor of the woman who helped discover the double helix structure of DNA. The rover will land on Mars in 2021, where it will continue our search for life on the red planet.
Thank you so much, Sarah. And finally this week, we turn it over to Dr. Tamitha Skov for your latest space weather.
Space weather this week is getting very exciting. As we switch to our front side sun, you can see that massive coronal hole that's rotating into the Earth strike zone. It's sending us some fast solar wind, and on top of that, we have a massive solar storm launch. That is launched just to the west of Earth, but when it arrives, it could be arriving coincident with that fast wind, and it could intensify the solar storm starting around the 28th and bring aurora to mid-latitudes. Now, as we switch to our backside sun, you can see that bright region emerging in stereo's view view, that's good news for amateur radio operators and emergency responders who are beginning to suffer with poor radio propagation. As this region rotates into Earth view here over the next week, it could easily boast that solar flux and get us back into the marginal range, and it gives some decent radio propagation on Earth's day side. Switching to coronagraphs that allow us to see the solar atmosphere just like we would during an eclipse. If we look at the raw images, you can see that solar storm being launched, but it looks really tenuous in white light. But if we switch to difference images that allow us to see the changes really spectacularly, now you see that big monstrous solar storm being kind of shot out like a circular blob, and you can tell because of the width, it's not that wide, and so we know that it's launched westward of Earth, so it's not going to hit Earth directly, but we still could get clipped by its wake. Switching to our solar storm prediction model, ENLIL, this is NASA's version of the model, and we're looking down at the sun from the North Pole. So you can see here's the sun, here's Earth, and here's that solar storm being launched just west of Earth. And as you can see, it's going to miss Earth just barely, but it is embedded in the spiral arm of that fast solar wind, and this means we could start seeing effects around the 27th, but then we might even get an intensification from the wake of that solar storm right around the 28th. And this is good news for aurora photographers because it could mean aurora actually will dip to mid-latitudes. Switching to our moon, we are now passing through the third quarter moon phase on our way to a new moon. And even by the third, the moon should only be about 10% illuminated. Now this is good news for you night sky watchers. You can easily catch some dim objects. You might even be able to get some aurora pretty easily. For more details on that coming solar storm, like when and where to see aurora, how it might affect your GPS reception, and how it could impact emergency radio communications, come visit my channel or see me at spaceweatherwoman.com.
We don't have a live show this weekend, but remember, SpaceX is slated to launch their DM-1 mission this Saturday, March 2nd at 7:48 Universal Time. This will be the demonstration mission to prove out the Crew Dragon vehicle prior to astronauts flying later this year. For those of you in the U.S., remember that it will be scary early in your local time zone. And before we go, I wanted to take a moment to thank all of the citizens of tomorrow. Since our shows rely on crowdfunding, these are the people who helped to bring this episode to you. If you're interested in helping us out, head on over to patreon.com/TMRO and consider contributing whatever you feel the shows are worth. Thank you so much for watching this week, and I look forward to talking to you tomorrow.